If the price P of a candy bar is P of X equals 165 minus X over 10 cents when X thousand candy bars are sold, we want to first find the expression for the total revenue from the sale of X thousand candy bars. Now, there are two things about this problem that are especially important to pay attention to, one of which I've already highlighted. X is not the number of candy bars sold, it's the number of thousands of candy bars sold, first of all. The second thing is that this is in cents, not dollars, and you're so used to working in dollars. You need to be careful about that. Given those two things, though, let's go for it. They ask us to find the total revenue. Well, you've worked with revenue enough already, I hope, that you know the total revenue function is the price per unit. In this case, we're selling candy bars, so it's the price per candy bar times the number of candy bars sold. So revenue is always price times quantity. Now that seems simple enough, but there's a couple of things here you've got to be careful about. The price per candy bar was given to you, so in that sense you're lucky. Here's the part I'm worried about you getting confused on. It says the number of bars sold, but X is in thousands of bars. This is the price per bar. If I just write X here, then I'm saying that's the price for every 1,000 bars, but that is not what it says. P is the price per candy bar. So if X is the number of thousands of bars, the number of bars sold is not X, that's X thousands, it'd be 1,000 times X. So if X is 1, that means you're selling 1,000 bars. If X is 2, you're selling 2,000. If X is 10, you're selling 10,000. And this is the price per bar. So it's the price per bar by the actual number you're selling. And since the X is in thousands, if you don't make that adjustment, your revenue function is wrong. So that's an extremely important point to make. Assuming you're with me on that, now it's simple enough just to multiply this out. 165 times 1,000x is 165,000x minus x over 10 times 1,000x. X times x will be x squared. The 10 goes into 1,000 and leaves 100, so you get 100 x squared. So that's the tricky part here. Thousands of units versus the number of bars sold. You got to be careful. Given that, finding the revenue function is pretty straightforward. So that's the A part. B part says find the value of X that produces that maximum. Well, the same old routine. You take the derivative, which would be 165,000 minus 200X. And then you set the revenue equal to 0 to find your critical number. Add 200x to both sides. Divide both sides by 200, and you end up with 825. So that's the value of X, produces maximum revenue. Technically, I don't know that it's a maximum, but I do know that this is a parabola opening down. It will be a maximum. But if you want to actually use the first derivative test to make sure, absolutely certain, you just take a number smaller than 825, say 0, plug it in here, and you get a positive value. You take a number bigger than 825, say maybe 1,000. 1,000 times 200 is 200,000, and 165,000 minus 200,000 is definitely negative. So that is a max. So yes, 825,000 units, but it says the value of X is 825. But remember, that really represents 825,000 bars sold. And the last part says find the maximum revenue, and you simply do that by putting 825 into the total revenue function in part A. So you end up with 165,000 times 825 minus 100 times 825 squared. And I'm not going to bore you with the arithmetic, but when the arithmetic is done, you end up with 680 62500. And here's the other problem if you're not careful. Remember from way back long ago, this is in cents. So this is how many cents profit there are. We probably want to rewrite that in dollars. Remember, you just move the decimal place 2 places to the left to change dollars to cents. We probably don't want to leave that in cents. So that would be 680,625. In other words, $680,625. So the second point of confusion is forgetting to change your cents to dollars in the end.